Have you ever wondered how fast electricity travels? It's a question that sparks curiosity, and as it turns out, the answer isn't as straightforward as you might think. Imagine the flow of electricity as a bustling city. The electrons, the basic carriers of charge in the city, are like the cars. They are constantly in motion, but their progress can be slow, hindered by traffic and obstacles. This is what we call drift velocity. It's the average speed of these electrons as they meander through a conductor, like copper wire, nudged along by an electric field. This pace is typically measured in millimeters per second, which might seem slow. But remember, we're talking about a microscopic world here. Now picture a wave of change sweeping through the city, like a new trend or a breaking news story. This wave doesn't have to move at the same speed as the cars, right? It can ripple through the city much faster, reaching everyone almost at once. This is akin to the signal propagation speed in electricity. It's the pace at which changes in electric potential, like voltage or current, spread through a circuit. This speed is where things get really fast. In a perfect world, with no resistance or other factors to slow it down, the signal propagation speed would be close to the speed of light, a blistering 186,282 miles per second. But in real-world electrical systems, this speed can be slower due to various factors like the capacitance, inductance, and resistance of the conductors and components involved. So, while the individual electrons may be taking their time, the electrical signals are racing ahead. This is why, when you flip a switch, the light turns on almost instantaneously, even though the electrons in the wire are drifting along at a leisurely pace. In summary, the speed of electricity is a tale of two velocities. Drift velocity, the slow, steady march of electrons through a conductor, and signal propagation speed, the lightning-fast spread of electrical changes. Even though the actual movement of electrons is relatively slow, the overall effect is quick due to the rapid propagation of electrical signals. This fascinating duality is what allows our modern world to stay so brilliantly connected and electrified.